Alright, so percent composition is the percentage by mass of each element in a compound and is given by the following equation. Molar mass of element multiplied by the subscript divided by the molar mass of the compound times 100%. So that is your percent composition by mass. Let us have our first example. What is the percent composition by mass of each element in H2O? Okay, so here we have to determine first the molar mass of the entire compound, which is in the form of H2O. So the molar mass for this, molar mass of H2O is equals to 18.015 grams per mole. Now let's take in the individual element. Okay, so let's start with hydrogen. Hydrogen is equals to the molar mass of the element multiplied by the subscript. So that should be 1.008, okay, multiplied by 2. The subscript is 2 divided by the molar mass of the compound, which is 18.015 grams per mole multiplied by 100%. Okay, and this will give us 11.19%. Let's go to the second element, which is oxygen. Oxygen has a molar mass of 15.999. Then there's only one oxygen present, so we multiply it by 1. Okay, and then divided by the molar mass of the compound, which is 18.015. Then we multiply it by 100%. Okay, and this will give us 88.81%. Okay, so if we check the sum of this, okay, it will be 100%. Okay, example number 2. What is the percent composition by mass of each element in potassium nitrate or KNO3? So the molar mass for KNO3 is equals to 101.10 grams per mole. Now let's deal with the individual element. So let's start with letter K, or with potassium rather. So it's K is equals to the molar mass times the subscript. The subscript is 1, so that's 39.10 times 1 is 39.10 divided by the molar mass, which is 101.10 multiplied by 100%, and this will give us 38.67%. Okay, for the second element, nitrogen, we have 14.01 multiplied by 1 is still 14.01 divided by the molar mass of the compound. Again, this is the molar mass of the compound, 101.10 multiplied by 100%, and this gives us 13.86%. Alright, now for the last element in the compound, which is oxygen, so you will notice that it has a subscript 3. So we have to multiply the molar mass of oxygen with 3 or by 3. So that will be 15.999, right, times 3 divided by the molar mass of the compound, 101.10 multiplied by 100%, and that will give us 47.47%. Okay, and then when we add all of this together, have 99.9% or 100%. Right, example number 3. What is the percent composition by mass of each element in CaOH2? So the molar mass for that compound is 74.0 grams per mole. So let's have the first one, calcium. Okay, calcium is equals to, so it only has one calcium present here in the compound, so that will be 40.078 divided by 74.09. 74.09 is the molar mass of the compound multiplied by 100%, and that will give us 54.09. Right, for oxygen, okay, oxygen is inside the parentheses, so since it is 1, we have to multiply it by 2. Okay, so that's 1 times 2 equals 2, so therefore we will have 15.999 multiplied by 2 divided by 74.09 multiplied by 100%, and that will give us 43.18%. Let's write down the percent here. Okay, for hydrogen, right? So same procedure with oxygen. So hydrogen here is 1 multiplied by 2. So that means we have to multiply the molar mass of hydrogen by 2. So that will give us 1.008 grams per mole multiplied by the subscript divided by the molar mass of the compound, which is 74.09 grams per mole multiplied by 100%. And that will give us 2.72%. So to check, this will be 100.02 or just simply 100.0 or 100%.